Okay, so this is the ASTOS SkillDev. This is kind of our ASTOS process as of June 2022. We are looking to upgrade this, but this is just for documentation purposes for future work. So the first step of ASTOS is to actually go into RazAero and build your airframe in RazAero. There's already a tutorial on how to do this, so I kind of skipped this part. This is the Xenia 1 airframe. And then all you need to do is go arrow plots. Arrow plots, and then you just go file. Incredibly smooth. Export to CSV. And you basically just need a CSV of that data. You don't need to insert masses or anything. It's just the ASTOS is going to read the drag and lift coefficient from RazAero. So, the first thing you should download the most recent ASTOS file on the drive. So I've already done that and changed the date to today's date. So there should be a .gdp. This is HIAC1 just because it did not get renamed from HIAC1. So just ignore that. And then I've gone ahead and put the CSV, which is just the CSV we've exported from RazAero. It doesn't need to be in the same folder, but it's just convenient. So I am going to open that CSV. We're basically just copying data. And if you go into the GDP file, GDP model, and if you open the input data folder, this is the main kind of data entry folder. So first thing I tend to do, so you need to go over to the CSV from RazAero, the single page, mock, PDCL basically. Hit in the corner, Control A, Control copy, and then you go over to the input data, and in the raw RazAero data tab, I'm going to paste it. And so now it's updated all those cells. I guess it's worth noting, if you haven't updated the airframe, you don't really need to update this data tab. This would only change if you say change your fins, change your fuselage, stuff like that. Hit save. You'll probably get this weird compatibility thing. That's okay. There's a bunch of different tabs, but the main tab you will work off of is the stability tab. Or sorry, the error tab. So right now, the kind of data input cells are the green ones. So total rocket length is 114.7. So we can measure that in CAD, which should hopefully be right. It's actually 115.3 inches. And the cell below is just like a conversion. So originally we had this configured that the payload was kind of a separate component. When I took this project on, me and the person who was working on it, we decided that was kind of silly, like what is necessarily part of payload, what is not. Payload can be split up in the rocket. So we just entered 0 for all the payload stuff. We don't think it affects anything based on our testing. The launch rail, which is like the length of the first launch slug, does not need to be changed unless you change your launch rail. So now you have to enter your center of gravity location. So you need full and empty locations. So these are measured from the nose cone tip, and they're measured in meters. So everything ASTOS is going to take in is going to be in meters. So to do that, So we have our field grain in CAD right now. Let's see this plane. Okay, perfect. And we have this plane. So if we measure between the plane and the center of mass, I highly recommend putting a nose cone tip plane, 74.6 inches. This where it gets annoying because you need to convert. (74.6), 1.89 meters. What we have, empty after burnout. So in that case, the fuel burn, or the fuel will be burnt out. So the fuel grain be non-existent. So you go into the CAD and suppress that part. Make sure that you rebuild before you recheck that. So Control Q or Control B will rebuild in SolidWorks. So now center of mass. (68.84). (1.7). And then again, everything with the payload, we just at 0 and we just consider the rocket. Basically in ASTOS, if you have a payload or if you have like a separate component, you can like jettison it, which I guess if you ever wanted to make a payload that you jettison during flight, that might be a useful thing for us. But right now we're not really, we're just concerned with ascent, and we don't have any payloads that we just drop during ascent. So. And then you need the empty mass of the rocket, which again, you can get in SolidWorks. Take a second to load. Okay. 17.7. So yeah, I don't think the CAD's really been updated much since the last time I did this. But save everything. This is in kilograms, by the way. Everything for ASTOS is in like base metric units. This reference length, if you ever change the rocket diameter, you do need to change the reference length. But for us, it's the same fuselage diameter. So if you go over to the stability tab, what it does is for various motors, I think it just plots how the CG changes, or the center of pressure changes over Mach. I'm not quite sure. So then there's several, well, let's just go through all these tabs. So the raw res aero tab is where we pasted all that data in. This data for desired Mach, I'm not 100% sure what it does, but it just, I think it is just organizing the like kind of Mach range of that raw res aero data, because this will plot to like Mach 20 or something. We're not really interested in that. And then metric, I believe, is just the metric version of that, which is a little confusing to me because I think these are all non-dimensional. I'm not really sure what the difference between metric and the other one would be, but seemingly it's the same thing. Arrow is all our input data. It takes the So CN alpha is like the normal coefficients, so it's like the lift coefficient, COP, center of pressure. Unfortunately, it's like very disorganized. Like this is from the RAS aero data. Down below is recovery stuff and some weather stuff, which we haven't really used a ton. Honestly, we just kind of look, or since we're just looking at apogee, we don't really worry too much about recovery, haven't played with it much. And then there are the remaining tabs are the motor tabs. So for a given off-the-shelf motor, you can get the curve from thrust curve, and you can get time versus thrust and mass. At a time, it will deliver a certain amount of thrust and it will have a certain amount of mass left in it. And then the impulse is basically, what is impulse? It's like force times time. So in that delta T, how much force is been applied. And for some reason, it copies like the stuff from the arrow table. I don't think that's super important. We have one for most of the motors, like motor candidates we have. We did run into a bit of trouble for Xenia. Like you'll notice these are all N or O size motors, which are quite large. So for Xenia, this N5800, this is actually the M2505. I was unable to figure out how to make ASTOS read another motor, so that we had to basically just overwrite the motor data, which is not very good, but at least we can kind of run with that for now. So this is the data that ASTOS is actually reading. Yeah, so that's kind of your mostly done for input data. Then there are a couple of sort of janky things you have to do. So if you go to the stability tab for the motor you have, so I did update this as well. So it's also this actually the M2. So copy these values into this text box. So you highlight all these blue values, copy, and in that same model, you have this like DX, whatever this is, and you just overwrite those values and save it. And then the other weird little text file thing is these guys, CA. You copy all those, and then you copy them into CA, the other text file. Now, I'm not sure why these are text files, because you can just, I think, tell ASTOS to read Excel cells. So that's another feature thing, eliminating these files, because it's a little silly. So now we are for real done. Now we open ASTOS. So the hard part is mostly done. You go to the prompt. So I've kind of been doing stuff. So there are some logs that you can ignore. So we need to go into the model browser. Well, okay, I'll just pause. Do you guys, has this made sense so far? Yes, okay, nice. So now we need to go into the model browser, which is in setup, model browser. There's not a ton you usually need to change, but you do need to check. So under model definition, okay. Hello. No, it's not loading for some reason. Okay, so I will, sorry, you normally have to go problem, open, and you need to open wherever that problem is saved. So for me, it's this guy, and you have to actually open the .gdp. So open that. Okay, there we go. I think I just had the wrong thing open. So yeah, let's quickly show you the tabs. So for atmospheres, we have just like standard atmosphere. I think this just comes with it. Celestial bodies. So I mean, we are launching from Earth, and it is a sphere. We don't have to be launching from Earth. If you ever wanted to, I don't know, do a mission from Mars, I guess you could do that in ASTOS. There's some wind data, which I think is from like the Vegas area, which is kind of close, or I don't know, it's from kind of close to competition for SAC at least. Aerodynamics. If you change the reference, if you change the rocket diameter, you would need to change the reference length and area. Drogue chute and main chute is for recovery stuff, which I've never really touched. Propulsions. So here's where it loads in all the motor data for all these motors. So again, the N5800 is actually the M2505, the Xenia motor. And then components. So you should see whatever the rocket name is called. For some reason, the name from Hayek 1 has gotten dragged over. Need to make sure that the structural mass is updated. So in that case, it's 17.77 kilograms. The structural mass is the dry mass. Propellant. If you change the motor, update the propellant. In our case, it's 3.34 kilograms. And that's good. And then you can just check. So phase configurations is just like kind of the different stages of launch. You have this initial time. Under initial state, you can set the launch altitude, which is 275 meters, the longitude and the latitude. Definitely make sure you update that if the launch location changes. Under ignition. So now the following tables all have these active propulsion system tables. You don't need to change anything. I'm just kind of showing you troubleshooting. So this is number of active propulsion systems, number of, I don't know what this is. And then that's the propulsion associated with it. So if you had multiple phases, you might have some propulsion systems that are not active. And we have takeoff. Again, we still have one active component. And then during motor thrust, again, check the motor's still active. Coast to apogee. See, we have 0 active motor systems because now we're just coasting. And then you have drogue and main deploy. Mission definition, it just shows basically all those phases. Probably this is causing the name to be Iguanas to Xenia. I won't change that in case something goes wrong, but we can try changing that. So then the other thing to know is the ODBC. So this is kind of, it's for something database connections. So basically this is where it's getting, you see coefficient of drag, it's reading from these cells in the arrow sheet of that Excel file. So that's good. And yeah. Profile is thrust profiles, I believe. Yeah, so it's basically reading drag and alpha, which is lift, velocities, reading all that from the input data. So now you're kind of done with all the input. So I'll hit save and close the model browser. And now you need to initialize, update model. That should be very quickly. And then you initialize, hit initialize. And this will take a second to load. So how you can kind of test if your license is working. Hopefully, generally, if you make it this far, you have a license because they've successfully gotten a license. Unfortunately, the feedback is not very good on this, but you can kind of see sometimes, or in the past, I've had troubles where, it will kind of like quit on one of these phases. And so then, like, oh, if there's something wrong with phase 3, I think that's like liftoff or something. So you can check the things associated with liftoff. Like, hopefully that makes sense. So now we have initialized, we need to actually simulate. So you need to go simulate. I'm not 100% sure. I think the connected phases is the best one to use, but I'm not really sure what the difference between those 3 are, honestly. So now it will take a second to simulate. Next. So yeah, so anytime it says status 0, that's blue, that's good. So to kind of check, I like before, so next thing you can do is export your results. However, I like to make sure that it actually saw my new changes. Sometimes it doesn't like update things. So to do that, you can go set up problem summary. This is just like a good way to know that like your overall inputs are right. So here's your starting altitude, longitude, latitude. So then here's your phase description. So I think this is initial liftoff, thrust. Yeah, this is motor thrust, and then this would be coast to apogee. Yeah, initial liftoff, thrust, coast. You can see like the active total thrust. You can make sure you haven't jettisoned anything that you weren't supposed to, and make sure the motors are active when they're supposed to be. Structural mass 17.7, propellant mass 3.34. So we are looking correct. That's the general things I look for. So problem summary, good. To get your results, well, first of all, you can do a quick view, and you can plot all these things. Honestly, I don't find this very useful. But there's like a plot. So the green is the altitude in kilometers. That's the other thing, you're going to get altitude out in kilometers. And then your Mach number, which we have about 0.9 Mach, sounds right. But usually I just find it a much easier just to export the results. So we go result, export. So basic, so make sure you're in the right, okay, yeah, so make sure you're in the right folder. And then it will just export it to a text file. So I'm just going to call it Xenia 22.6.2. It'll take a second to do that. While we are So there is also an output data spreadsheet. Basically, all it does is parses that text file and makes like a nice graph for us. We go back to ASTOS. Okay, so we've successfully written that text file. If we open the text file, it gives you like everything under the sun you could need. Control A, control copy, and you can just paste that right into the raw output. And you'll kind of see like all the columns stay the same and the numbers then update. And if we go, we get our altitude versus altitude and velocity versus time. So this kind of just like segments out for us altitude for time, phase, altitude in kilometers, feet, time, velocity, mass. It just kind of segments the important stuff. So you notice you start at your starting elevation, in our case like 900 feet. And then these two squares pick the max out of this one, out of the altitudes. And then this subtracts your ground level so that you get your altitude AGL above ground level. In our case is 11,800 feet. And that's pretty much all there is to it. Just make sure you save everything and then upload the dated ASTOS file to the drive. Any questions? There's all kinds of like auxiliary data you can get. Yeah, like see, this goes on literally almost forever. Yeah, that is ASTOS. Definitely looking to improve it and move to ASTOS 9, but that is what we're using right now.